everyone. In this video, we will be simplifying rational expression, and this is the second part. I will put the link of the first part in the description box below. Let's take this first example right here. So we have 10x squared y to the 8th over 4x to the 7th y to the 3rd. There are steps that we need to follow in order that we can simplify rational expressions. The first step is to factor out both the numerator and the denominator. So in this problem right here, I can go ahead and factor out the 10. So the factors of 10 would be 2 and 5. So I can go ahead and write 2 times 5. And then this x squared means that there are 2 x's. So I can go ahead and write 2 x's after that. And then for the y here, it says that there are 8 of them. So I'm just going to go ahead and give space for the other x's, which is 7 at the bottom here. So I can go ahead and write the 8 y's on the other side right here. So I got the 8 y's. Again, I put a space so I can fit this 7 x's at the bottom. So then I go ahead and factor out the 4. So that would be 2 times 2. And then there are 7 x's. And there are 3 y's. So that would be y, y, and y. Okay, so after writing it all out, we're ready to move on to the second step. The second step is to simplify. In order that we can simplify this, we remember the division by itself property, which states that if we divide a number by the number itself, then the quotient is 1. So if we have a 2 over 2, this is actually 1 right here. So I can write 1 on that one. So 2 divided by 2 is just 1. And then we have x, x, and x's here. So we can go ahead and put this all as 1 right here. So this is another 1 because again, based on the division by itself property, if we divide the number by the number itself, then a quotient is 1. So 2x's divided by 2x's would be 1. Now let's look at the y here. So we're going to divide these 3y divided by the 3y here. So this is another 1 right here. Now others are going to say that, oh, can we just cancel them out? Yes, we can cancel them out. Again, if we cancel them out, we remember that they are not, when we cancel them out, it doesn't come out 0. It is actually 1. So you can, others would want to cancel this out. That's fine too. It means the same thing. But we remember that when we cancel these out, it is not 0. These two are not 0, but instead it is 1. So then we can go ahead and simplify this. Whatever the leftover, that would be the final answer for this rational expression right there. So we're left with first, there's 5. And then on top, there's another 1, 2, 3, 4, 5. There's 5y. So I can go ahead and say y to the 5th power. That tells me that there are 5 y's in there. And we have a 2. And then there's like 1, 2, 3, 4, 5 x's. So I'm going to write 2 x to the 5th power. So then we can go ahead and say that this expression right here can be simplified as 5y to the 5th over 2x to the 5th. Now, there is another way to do this using the properties of exponent. We can go ahead actually and write out, so pretty much the same thing. So I go factor out the 10. So that would be 2 times 5. And then I go write x squared. And then for the y, I will have to make the y even with the bottom. So I can go ahead and say y to the 3rd and y to the 5th. The reason why I split this into 3 and 5 so that I can cross out the y to the 3rd at the bottom. So I can go ahead and say that I can rewrite the bottom. So then we can go ahead and say that the leftover would be 5. And then it's pretty straightforward now. That's y to the 5th. So that's y to the 5th. Over, again, this was 2 and 2, so I corrected it. So that would be 2 times x to the 5th, because again, these are crossed out. Again, we remember that when we cross out, we are not actually making this equal to 0, but instead, these are actually 1. So both of these methods will give the same answer, which is 5y to the 5th to x to the 5th. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to factor out both the numerator and the denominator. So in this problem right here, others are going to say, oh, we can just cancel them out because they're just pretty much the same thing. They both have x and 2 and x and 2 right here, so we can just cross them out. We can't actually do that because if we look at this, the x is negative because you have a negative x and then the x here is positive. On top, the 2 is positive and then the 2 here is negative. So what are we going to do now is we factor out the top. So we can actually factor out -1. We use the distributive property backwards. So then we go ahead and write. So in order that we can have a +2, I'm going to have a -2. So if we distribute, -1 times -2 is a +2. And then I'm going to have a plus x here. So that if we distribute this, -1 times -2 is a +2. -1 times positive x is a negative x. And that is over, we copy the same thing, that would be x minus 2. Now, we remember that we can switch this around. So if we switch this around, we can go ahead and say that this is equal to -1. And then that is, write the positive x first, and then the -2, and that is over x minus 2. Now notice that the x minus 2 and x minus 2 are the same. So we can go ahead and use this property, use the division by itself property, that if we divide a number by itself, the quotient is 1. So we can cross this 2 out. Now again, remember, once we cross out, it is actually 1. So then we can go ahead and say that the answer is -1 times 1 is actually -1. So the final answer for this is -1. So I'm just going to go ahead and put this inside the box. Did you get the same answer as this? Good. Perfect. Now let's move on to the next set of examples right here. We're supposed to simplify 8x squared plus 12x over 4x plus 6. Again, in order that we can solve this kind of problem, we're supposed to follow some steps. The first step is to factor out both the numerator and the denominator. So in this problem right here, we can actually factor this out. We can factor out the GCF for this, and then we do the distributive backwards. Now others are going to say, how do we factor using the GCF? Now there's another video that talks about how to factor out a GCF from a given expression. I will put the link of that video in the description box below. So, but then in this problem right here, we can go ahead and look for the GCF. So I'm just going to show the work down here. So we're going to start by writing the, again, on the first step, we're supposed to factor both the numerator and the denominator. So let's start with the numerator first. So I can go ahead and write 8x squared plus 12x. So we're going to factor that out. And then at the same time, we're going to factor as well the denominator. So I'm going to show the denominator right here is 4x plus 6. So we're going to factor it out. We start with 12x. So we're going to determine the factors of 12. So the factors of 12 would be 2 times 2 times 3. That's 12. So 2 times 2 is 4. 4 times 3 is 12. And then times x. So that gives us 12x. Now this 8x squared can be factored out as, that's going to be 2 times 2 times 2. So 2 times 2, 4 times 2 is 8, and then there are 2 x's, x and x. So we are going to determine the GCF. The GCF would be the ones that are common to both of them. Again, there's another video on how to determine the GCF. I will put the link of that video in the description box below. So these are the common factors for 8x squared plus 12x. So the GCF here is gonna be 2 times 2. So that's 2 times 2. And then we have another x, which is actually equal to 4x. So the GCF is 4x. Now, we use the distributive backwards to factor this out. So I'm going to write 4x here and then parentheses. Now, we determine what do we write inside the parentheses. You can actually divide it. You can go ahead and say x 8x squared divided by 4x is actually 2x. I can go ahead and write 2x right here, so that if we use the distributive property right here, 4x times 2x is actually 8x squared. And then we're gonna have the second term, which is plus 3, because if you divide 12x divided by 4x is 3, or you can use the distributive backwards, that would be 4x times 3 is 12x, which means that this numerator is actually this one right here. So I'm just going to go ahead and write that up here. Okay, now we're ready to factor out the denominator. So we do exactly the same thing here. We determine the GCF. I'm just going to show the work down here. Okay, so I factored it out, and so this 4x plus 6 can be factored as 2 parentheses 2x plus 3, so that if we distribute 2 times 2x is actually 4x, and 2 times 3 is 6. So we can go ahead and rewrite this here as it's going to be 2, and then parentheses 2x plus 3. And so we can go ahead and use the division by itself property. If we divide a number by a number itself, then the quotient is 1. So this expression that we have here is actually 1 right here, because you see the numerator and the denominator are the same. Again, others would want to just cross this out, but then again, we remember that when we cross out, that's actually using the division by itself property. It's actually equal to 1 and not 0. So that's the very thing that we need to remember. So in this case right here, we can go ahead and we're left with 4x over 2. We can factor out some more. 4x is actually equal to 2 times x, and then we have a 2 at the bottom on the denominator. So then we remember the division by itself property. If we divide a number by a number itself, then the quotient is 1. So this one right here is also 1. Again, we remember that we can cancel them out. So if we cancel them out, again, it's not 0, but it is actually 1. So then we can go ahead and we're left with 2x. So our final answer right here would be 2x. So this is 2x right here. So we go ahead and put this inside a box. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to factor out both the numerator and the denominator. So in this problem right here, I'm just going to show the finding for the GCF. So we're going to factor out the GCF from each of the terms here. So I'm just going to show the work down here. Okay, so I factored it out and it came out to be like this. Now we remember, just like the second example that we had in the previous slide, that this actually can become -1. So I'm just gonna show the work right here. So we can go ahead and simplify this some more. So then this y minus 4 and y minus 4 using the division by itself property, that if we divide a number by the number itself, then the quotient is 1. So then we can cross these two out. Again, when we cross this out, we remember that it is 1. So then we can go ahead and say that these two can also get crossed out. And then the 2 and the 2 can also get crossed out. So we are left with 3 times negative 1 is actually negative 3. So then we can go ahead and say that the final answer for this is negative 3. So this is the simplified version of this rational expression right there. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!